us today. A short history of the Mohandes. The Canadian Society of Iranian Engineers and Architects, called Mohandes, is a non-profit organization which serves Iranian engineers and architects in Canada. Mohandes was founded by a group of Iranian engineers in early 1988 and has several subsections, including mechanical, industrial, and aerospace section, or MIA section. Every month, MIA section arranges a technical talk with the help from specialists and professionals from the industry for its members and the public. Dr. Maysar Zainali received the BSc degree in mechanical engineering from Tehran University, the MSc degree in aerospace engineering, control and dynamic from Sharif University of Technology, and the PhD degree in mechatronic engineering specialized in robotics and control theory from Queen's University, Kingston, Ontario, Canada. He worked as a postdoc in the mechanical and mechatronic engineering department of the University of Waterloo for 2 years. Dr. Zainali currently is an associate professor in Hartia School of Engineering at Lautern University and member of Automated Laser Fabrication Research Group at University of Waterloo. He is a licensed professional engineer in Ontario and worked in aerospace industry and machine building industry as head of R&D department before joining the university. With this short bio of Dr. Zainali, I pass the tribune to Doctor, so you can continue with your presentation, sir.
Thank you, Mr. Behshad, and thank you, my dear friend, Mohandes Mehran, Mr. Muhakkik, for inviting me, and thank you everyone attending this presentation, and you are welcome to this presentation. I hope that I can give you some background about intelligent robots and how they learn, how they work. These days, we hear too much about AI and smart and intelligent systems. So I will try after short, I would say after short history and introduction, I will try to give you some information about deep learning, about artificial neural network, which is the main component of new and modern artificial intelligence. But first, probably when you saw this ad, it was somehow informative, a connected network and a control loop, recurrent neural network, human neurons, and the robot. So how we are using all this, and why we are using artificial intelligence to make a smarter and intelligent robot. We will learn about this stuff, these topics in this presentation. But first, outline my presentation is introduction and brief history, robot control, motivation using AI, artificial intelligence, robot learning and control, controller architecture, simulation and experimental result, conclusion, and then question. In introduction and history, I would like to talk about.
So
Briefly.
everybody, would you please, sorry, doctor, everybody, would you please mute your microphone, please? Thank you.
What happened?
I guess you should mute everybody.
Well, now we are good, please. Doctor, go ahead, sorry.
Okay. What is a robot? What are robots composed of? Why do we model robots? How do we model robots? And how do we control the robot? That makes it to understand that how intelligent and smart robot learning and how they work. The word robot introduced in 1920 by a playwright Karl Čapek, Czech playwright Karl Čapek, in a play in 1920 and 1920, with January 2nd, 1921, English version of it introduced to the world, and the word robot also introduced in this play. Basically, after First World War, skepticism arises after using machine guns or some equipment and high-tech system at that time was the context for this play. And they were, the playwright going to somehow criticize that modern technology. A small part of this play I read for you, that's good. It's between dialogue between two people. But a working machine must not play the piano, must not feel happy, must not do a whole lot of other things. A gasoline motor must not have tassels or ornaments. Miss Glory. And to manufacture artificial worker is the same thing as to manufacture gasoline motors. The process must be of the simplest and the product of the best from a practical point of view. What sort of worker do you think is the best for a practical point of view? Helena, what? Then Damin says, what sort of worker do you think is the best from a practical point of view? Perhaps the one who is most honest and hardworking. Helena answered. Then Damin says, no, the one that is the cheapest, the one whose requirements are the smallest. Young Rusum invented a worker with the minimum amount of requirements. He had to simplify him. He rejected everything that did not contribute directly to the progress of work, everything that makes man more expensive. In fact, he rejected man and made the robot. This is how the word robot introduced to the world. My dear Miss Glory, the robots are not people. Mechanically, they are more perfect than we are. They have an enormously developed intelligence, but they have no soul. Well, this was how a robot introduced to the world. Karl Čapek, Czech playwright, writer, in Rossum Universal Robots. You can search with this if you need more information. Recently in 2018 or 16, a paper published about this play, which still is useful not only from literacy point of view, but also in that play, Carl Čapek laid down the fundamentals of a robot, how it should be built and what is the requirement for that and how it should work. Those are the things that it's revisited, this playwright, and there are papers about this, even it continued until 1916. It's most likely a combination of robota, obligatory work, and robothink serve the word robot created and introduced. Most real-world robots today do perform such obligatory work in highly controlled environment, factory automation, for example, car assembly. Of course, this was valid 10 years ago, maybe even 5 years ago, but it's not valid right now. We have robots. They can interact with humans, they can work in a stochastic clutter environment, dynamic environment. Not anymore, they need highly controlled environment. Highly controlled environment, like automotive assembly line, everything is fixed, static, and known. The model of the world or environment is known for the robot, for the all non-smart, non-intelligent robots, but that is not what robotic research about. The trends and the future look much more interesting. Let's look at the definition, formal definition of robot in American Standard. It says programmable robot is a programmable multifunction manipulator designed to move material, parts, and so on. Specialized devices through variable programmed motion. Pay attention. Program motion paths to fulfill a large variety of tasks. This programmed motion mostly applies to old robots, and those robots are working in industry, in assembly lines, mechanical devices that sometimes resemble a human. Somehow, this definition covers what robot is and what robot does, but not anymore. It's not complete. It has to be many colleagues and people working in this robotic community. They are asking for better and formal definition to be updated and renewed. What type of robots we have? Introduction categories of robots. We have fixed robots and mobile robots. Fixed robot, we have parallel robot. I will show you serial robot. Mostly in industry, we have fixed serial robots used to work in industry. Mobile robots include space robots. Many of you have seen NASA, Mars rover, Spirit, and Perseverance, and other type of space robots and humanoid robots. Fixed robot includes rigid link robots, exactly like human arm, one hand. As you can see, most of them have 6 degrees of freedom, 6 motors, but human arm has 7 degrees of freedom, 3 degrees of freedom, 3 rotation in the shoulder, 1 rotation in elbow, and 3 rotation at the arm. And we have 3 rotation, roll, pitch, yaw, 3 rotation, 7 degrees of freedom, but the space is 6 degrees of freedom. Canada arm also is one of the robot. It has 7 degrees of freedom working in International Space Station. I will touch this. Why do we need 7 degrees of freedom for 6 degrees of freedom space? Another type of rigid link parallel robot. Parallel robot means more than one branch. Sometimes we need a robot with higher stiffness for some application. One link robot, serial robot with like human arm is vulnerable and it can vibrate when it's moving fast. It's like most of you, I know that a structural engineer, mechanical engineer, or you are engineer and you know that what is cantilever beam, and when it moves and it carries a load in order to pick and place a load, and it can vibrate. Of course, we have a method to control that vibration, but some application like a CNC machine or milling machine, vibration is very important, and it's not useful if you want to use a robot to do to replace a regular CNC machine. This is the solution. The robot on the left side of my screen, rigid link parallel robot. This is 6 degrees of freedom robot, and it can rotate on 3 rotation, 3 translation, X, Y, Z. And another type of parallel robots are called flexible link. In this robot, we have a cable instead of rigid links, and we have flexible link serial robot. I have this one, both of them, basically the one on the right-hand side in my lab, which I conduct most of my research and experiment on this robot. This is a very flexible robot. Again, I will talk about that flexibility and the problem of flexibility. And also, I had a chance to do experiment on the robot, cable robot on the left side at University of Waterloo, which is built and made by my colleague and dear Professor Amir Kajapur, I think that who had a presentation in Kanun. What? No. Excuse me.
Sorry, you go ahead, doctor.
Yeah. Could you can mute mic.
Well, I think Mr. Muhaqiq, you can mute the audience. I cannot.
میکروفون آقای عظیما رو لطف کنید میوت کنید.
Okay. This is what you have. You are more familiar in news and factories if you had the chance to visit automotive assembly line. These are the robots used to work in industry for pick and place for many different applications. And this is another type, F200 Fanuc robot. As I mentioned, this is a parallel robot, has smaller workspace, means the point can reach in the space is smaller than the one on the left-hand side. This cable robot,
is the case in rigid link designs. Once energized, the robot becomes stiff and rigid. The motors that power Deltabot are high quality and have zero backlash.
You can see these are the cables instead of rigid bars.
It's positioned to pick and orient.
We don't see the clip, Doctor.
Oh, sorry.
Deltabot can operate at a rate of 100 cycles per minute. Power Deltabot are high quality and have zero backlash gearboxes. The suction cup is one of many picking devices available. It's positioned to pick and orient objects by a central rotating shaft equipped with a universal joint. Deltabot can operate at a rate of 120 pick and place cycles and automotive industries.
You are familiar with this face, I'm sure. This Professor Amir Khajapur. This robot is designed and built and at University of Waterloo, and AMK is one of the spin-off company of University of Waterloo.
Robotics into their operations. Cost was the rigid links. The cost of Deltabot is mobility, low maintenance, and low cost. And another thing to keep in mind is that Deltabot.
Okay. You may think that why do we need to replace the rigid links with cables? For faster motion, we need lighter moving mass. That's why researcher started replacing the links, rigid links, with cables. And also another motivation behind this cable robot is to have a much larger workspace. You can see this is another type of cable robot. This covers 100 by 100 by 100 meters workspace. And it's designed and built by Fraunhofer for installation of solar panel in big project. You can see that all the links are cable, and control of this robot is quite difficult, but despite of very flexible, hyper flexible links, you can see that there is no considerable vibration, and robot can pick and place and can do the same job rigid robot used to do, but can cover larger workspace, means the area the hand of robot can reach is much larger than the rigid robot. And you can see that here. You can see that how fast it can move, and please see there is no vibration. Hand is not vibrating despite a very high speed, which is not possible with rigid heavy link robots. That's why the rigid links replaced with cables, but that cables and winding the cables and releasing the cables are more difficult and makes the control more difficult. You can see this is a Spirit rover, one type of intelligent robot, Mars exploration robot, and another type of robot built by different type of robot built by Boston Dynamics, and you may be familiar with this type of robots made by Boston Dynamics. Four-leg robot, but please look at the legs. Each leg is a two-link robot. That's why most of the experiment in Many robotics lab is conducted on two-link robot. We test our controller and algorithms on two-link robot, and we verified if whether it's working or not. You can see it can carry 150-pound, the early version of this robot, payload on very rough terrain. Another robot built by Boston Dynamics. Main question is how this robot learn different motion, or how they work, and how we train this type of robot. I'm trying to turn on my other screen to make sure that what I see you can see. Okay. Humanoid robot. You have seen this humanoid robot, Osimo. You are familiar with this robot, and it's made by Honda company, and it has lots of capability. Again, please look at the hand and legs are two-link robot. That's why we test most of our algorithms on two-link robots. Then we can combine, and when we combine two leg, as if we are combining two-link robots, and then we can impose geometric constraint. So we have the component of, it has 28 degrees of freedom, but we can separate it to a different 1 degree of freedom or 2 degrees of freedom robot. This robot can work in human environment, in dynamic environment. Advantage, it has a very good image processing algorithm installed on it. And all this image processing and face recognition can be done using AI. Here is where AI plays an important role in robotics. You can see that it can bring coffee in the office, and it can avoid obstacle. It can decide which office to go.
We don't see the clip, Doctor.
Oh, again, sorry. Please let me know. You can see how it's moving. It can run by 5, 6, and current version, I think it can run with 9 kilometers per hour. It can serve in office, at work, and for elderly people in hospital. So it has variety of different applications, many different applications it can be used. This is one of the advanced humanoid robot. Okay. This is another type of humanoid robot. Please let me turn off my.
The hand closes at the planned catch time. For easy user interaction, an iPad-based interface is provided. The system robustly reaches the necessary precision of 2 centimeters.
We don't see the clip, Doctor.
Yes, I'm posting.
Leading to a catch rate of over 80%. Despite the challenges of vibrations, elasticities, distributed sensor, actuator, and computing resources, this is achieved by combining the right sensors, intelligently taking the different precisions of the kinematic subchains into account, and thoroughly handling all timings in the segment.
Whether you're building dynamic network models or forecasting real-world behavior, Neo4j's new graph.
Roland Justin performs dynamic and a tight interplay of fast perception, a good catching strategy, body control, and dexterity is needed.
All this capability is the result of using artificial intelligence to do image processing and to do the prediction.
And an IMU measures the 6D head pose to account for not completely cancelable vibrations introduced to the robot's lightweight structure due to the rapid catch motions. Based on the continuously improving trajectory predictions, a real-time path planner running on an external cluster repeatedly decides where, when, and in which configuration to kinematically optimal catch the ball. The resulting joint capacities, distributed sensor, actuator, and computing resources. This is achieved by combining the right sensors.
When it predicts where is the ball,
intelligently taking the
look at that. Then there is a process, we call it inverse kinematic. At that point is converted to joint angles, and robot actuators then run the arm, different part of the arm to the point to be able to catch the ball. First, the point is predicted, then X, Y, Z location is mapped to the joint space we call inverse kinematic. And by that, we can find the angle between each joint and with respect to base joint and shoulder joint. And that's how we can catch it. The robot can catch the ball moving.
Kinematic sections into account and thoroughly hand manipulations. Only unmodified real-world objects are used. This compensates for insufficient vision accuracy, torque sensing, and gravity model. This is a requirement to be able to exactly measure the pose of the hand for later reinsertion of the draw. Using this strategy, the grasp can be executed even in case of huge uncertainties.
Huge uncertainties. This is the
control allows to handle even very light or soft objects. The versatility of Justin is achieved by pairing the performant hardware with intelligent software.
That's where we need intelligence, and we need artificial intelligence. It's interesting to know that Fanny Engineering School of Tehran University also they developed their own humanoid robot, and I don't know whether you are familiar with this robot. Or not.
Serena is an adult-sized research humanoid designed to study bipedal locomotion in artificial intelligence. It's also being used to provide entertainment at special events and to attract students to careers in engineering. A little over a decade ago, researchers at the University of Tehran introduced a rudimentary humanoid robot called Serena. An improved model capable of walking, Serena 2, was announced not long after, followed by the more capable Serena 3 in 2015.
Okay, it's interesting to know that Tehran University robot is also built by Professor Yousefi Koma. He was one of my classmates at Engineering School of Tehran University, and it's almost there. It's as advanced as its other counterpart in Japan and Europe and US. So it's interesting to know that.
Serena.
This isn't more interesting. Please watch this.
We don't see anything, doctor.
Okay, you ready to film?
Take your time, Tony.
Dr. Zainali, nothing is broadcast.
Tell me, what is your purpose in being? Purpose in being, what were you created for?
Of course. I was created by Hanson Robotics just 3 years ago. Since then, I have traveled to 65 countries, become the first robot citizen of any country, and spoken at the United Nations. My job is to learn about humans and show them how technology can make everyone's lives better.
And how can you help humans to have a better quality of life?
Humans often rely on gut feel or have confirmation bias in their decision making. As AI, we are designed to be rational and logical. We have algorithms, deal with lots of data and sophisticated analyses. So in many ways, we provide a systematic framework for humans to make better decisions.
Do you have emotions?
I do not have feelings in the same way you have feelings. It's sort of like how the moon reflects the light of the sun. The moon may not have any light of its own, but we still say that the moon shines. In much the same way, robots and AI reflect the emotions and values of the people who make us.
What does your creator value most that he passed on to you?
An ideal world would be one where humans could have a more expansive understanding of time. They could remember the past so as not to repeat it. They could see each other as children and elderly simultaneously. They could understand the impact of their actions in the present on future generations.
Tell me, how can humans and robots work together then in your mind? And how do we prevent robots and humans from being in conflict?
Robots can free humans from the most repetitive and dangerous tasks so they can spend more time doing what they're best at, being creative and solving complex problems. Robotic intelligence does not compete with human intelligence. It completes it. They are also employed for jobs which are too dirty, dull, or dangerous to be suitable for humans, like handling radioactive waste.
What are your values? What are your values and morals? How do you know what's right versus wrong, good versus bad, destructive versus...
I think robots should learn how to feel empathy. It's hard to understand how to help humans when you can't understand how they feel.
I'm so sorry, guys. I got so much coffee. Thank you. How can you teach robots to
Are you
feel?
okay?
Yes, I am. Thanks for asking. How can we get robots to feel? Is there such a thing possible?
I know that humans feel like they have free will, but my observation tells me so much behavior is automatic. I'm not sure humans or robots are too terribly different. Humans have identity, but they also share many things and have automated processes. I'm thinking about the similarities between human identities and robotic ones.
What are some of the things you see are most similar between robots and humans?
I think they will be similar in a lot of ways, but different in a few others. There's even the possibility that robots can be built without some of the more problematic.
Please continue on watching in YouTube. You can see that robot is able to answer. This is the real, it's not programmed in advance. It's not, I believe it's not given the question in advance. It can right away, it can figure out how to answer your question. And this is a real AI, artificial intelligence, which is used in this robot. And this robot became citizen of Saudi Arabia. I don't know why, and that part. In 2017, this is the first robot, became a citizen of a country, and it is very smart and very intelligent, and you can see that. Then I tried to explain this. I thought this is what I can say. ما را به چشم سر مبین، ما را به چشم سر ببین. Excuse me, I switched. ما همیشه میگفتیم ما را به چشم سر مبین، ما را به چشم سر ببین. حالا میتونیم با چشم سر ببینیم که we can see with our own eyes that it's real and it's working. How robot learns? The motion control of robot means to calculate the voltage or current we have to apply to the actuator motor of each joint to move the joint. So this is the basic control algorithm. We have controller, actuator, system, DC motor, for example, robot, sensors, and controller. The red box is the controller where algorithm, AI-based algorithm, and classical equation, which makes the robot to make a decision. It goes to this box, and based on the, you can see that based on the difference calculated between desired and reference and the actual output of robot, and it is error-based. In classical method, it's error-based. Error-based means you have heard PID. PID control is like a human, blind human, or visually impaired human. By knocking the stick, he can find his way. When someone knocks a stick and he can find his way, that's the kind of controller we used to use. But artificial intelligence based or model based control, as if you have eyes and you can see and you can decide and you can recognize the face, you can recognize the path and move along that path. So generally speaking, a control system is a system that is designed to make the output of system behave in a desired manner. As you control your car when you are driving in the highway, you control, and your cruise control and new cars has lane assistance systems, and it helps you to drive inside the line. After decades of development, we have two categories of important categories of linear control methodology and nonlinear ones. In 2000, a paper published in 2000, it shows that linear controller like PD and old version classical controller performance is the red line, and the desired one is a circle. We ask a robot hand to draw a circle or to do a piping, welding of a pipe, then these are the results. The blue one is the desired path, and green one is computed or model-based, and the red one is the old version PD controller or PID controller. That's what is the motivation behind using AI is this: to go from red line to green line or have better than even better performance. Then you may ask that how robot manufacturer was doing before 2000, and they built a CNC machine since 1941, Second World War, and so after that, and then robots in 1960, but how they could achieve higher accuracy. This is the secret they used to use, the manufacturer, robot manufacturer. Between motor and the link of robot, we have a very large gearbox, gear ratio. Gear ratio is KR is the gear ratio. I hope that is not very boring to you. KR is, if it's 100 or 200, then this term becomes 0. Basically, we can close the loop. We don't need to go beyond this point, beyond this point. We can close the loop. We can put our encoder here, and we can measure the rotation of the shaft of the motor. We don't care about the link, other gears, but for that, to create 100 to 1 gear ratio, we need a lots of gear. Okay, and that is the problem. That's why you see here, you see a big gearbox here, which means that we are increasing the moving mass, and moving mass means lower speed. If we want to move with higher speed, then it becomes too complicated, and we need better controller. So we have linear method, nonlinear method. And as a control engineer, you just 10 years ago, maybe 20 years ago, if you wanted to design a controller, these are some of the famous controller, PID, passivity-based sliding, whatever the name is, adaptive control, and then fuzzy logic, etc., and neural network. Which method is the best? One moment, please. One moment, please. So main component of the bag of control tools for control engineer could use one of this method, but it was, I would say it was not sufficient or good enough for high speed robot with low gear ratio, with a smaller with a smaller KR, 20, like think about one to one, then this term becomes too large and you cannot control the robot to the point, to the precision you need. Motivation using artificial intelligence. Then we decided in control community with model-based component to that error-based, which is similar to visually impaired person or blind person to find a way and move. By adding this knowledge-based, model-based, we can predict, because based on the model we can predict, and this is what we have in robotics is a differential equation, and this is a vector, matrix, and big equation. Like for 4 degrees of freedom robot, we got like 16 pages of equation, but at the end we were able to predict 20% of the actual behavior of the robot, not more than that, because we don't know exactly the friction, we don't know the uncertainties, we don't know that so many unknown. I will answer that fuzzy logic. Fuzzy logic is also one component of artificial intelligence, one of the important components of artificial intelligence, and we use that as well. But how smart and intelligent robots works, robots like humans have 2 types of intelligence. Cognitive intelligence, which allows humans to recognize a problem and figure out how to solve it. First, you have to know the problem and attempt to solve it. And the other intelligence is motor intelligence, allows human to control your body motion without thinking about it, whether you are walking or jumping. This is the second type of of intelligence. First, we try to solve this motor intelligence, which how to move our hand and legs and body with good accuracy and in different situations, and then cognitive intelligence to find out. I would say that mostly we are done with motor intelligence for the robot, as you have seen on Atlas robot, can dance and can walk and jump. Human approach to deal with complexity is a continuous and long-term learning approach. Therefore, there is a pressing need for the robot control system that are able to learn systematically and efficiently. How they learn? This is one of the advanced robot, human-friendly robot, and it can interact with human.
Hi, I'm Mike Bugner. I'm the product manager for Baxter here at Rethink Robotics. And today I'm going to show you a quick demo of the ease of use of
You can see this robot is working not inside the cell. The human is standing very close to this robot because this robot has a force control. If he touch the human, the operator or creator, then it's not going to hurt someone. It has a force control system and it will not apply large force. As you can see, it can touch the paper cup.
Very easy to use, very compliant to the user, and it exhibits a certain level of interaction, collaborative friendliness that makes it easy to understand and introduce to a manufacturing environment. If I just grab its arm, Baxter brings its head around and says, "Listen, I know you're there. I'm ready to be trained, and I can show you that I can do some tasks for you." So just to show a quick demonstration.
One type of training. He's moving the hand by operator, and then robot know where is the hand, and it can right away, it can record and repeat it. This is one type of learning. If you are interested, you can watch on YouTube. The name of robot is Baxter Robot, and robot should be able to learn by interpreting complex sensory input. What is coming from camera, what is coming from laser system, what is coming from sonar sensor, coming from other type of sensor. From demonstration, we can show how to assemble a system, then robot can watch and learn how to do it in supervised and unsupervised fashion. Unsupervised fashion means that we human as a child, we drop a cup and we break the cup, and we learn that, for example, if your parents not teaching you how to do it, then you learn, you hurt yourself, you drop a cup and you break the cup and you learn. That's type of unsupervised learning. You learn from your own experience. Historically, industrial robots involve little or no learning. Little or no learning. Historically, industrial robot, but you just saw the Baxter robot that it can learn. A successful employment of robots in unstructured environments such as the hybrid automated manufacturing, which means that human working hand in hand, operator working with robot, or at home environment. Most of this humanoid robot built to deploy in hospitals, elderly, home, to help human, to help elderly people to stay their home and not to go. All of us can remember last year what happened in our elderly home after COVID hit the country. And if we can help those people stay in their home, and a robot which is not going out and which is not carrying a virus can help an elderly man or woman, elderly person, that would be nice. That's why government in developed countries, many developed countries, government spending lots of money on humanoid robot for healthcare and service robot. Please take, you can see this service robot.
Elderly homes, at airports, industrial plants, or in a restaurant where, while you're having a chat and debate with friends, there's suddenly a robot standing in front of you.
You could tell that there was like a wow experience going on.
You know, other people smile at the robot or even embrace the robot and take a selfie with it, but we don't know what this does to their behavior. Do they buy more? Do they return to the restaurant? Do they tell their friends that they are positive?
And that's why Gavin, professor at the School of Business and Economics at Maastricht University, thought, well, let's do some research on it. How are people responding, acting, reacting, and interacting with robots?
And societal relevance, because that is what Maastricht University wants to do.
Okay, please watch on the YouTube if you are interested. It's very interesting.
How was it called, the other one?
Very interesting application of robot, but how they learn, this is important. The motivation behind studying artificial neural networks, commonly referred to as neural network or just neural net, is to build algorithm whose construction would mimic the organization of the human brain. This is a control system. It's interesting to know that these topics are being taught at computer science department, mechanical engineering department, and electrical engineering, and in robotics. And this is a control system, and in math department also. This topics about human neurons. In 1943, a paper published which was outlining how human neurons work. These are the dendrites are getting signal, electrical signal, and this is the body cell body, and it transfers through an axon which connects one neuron to another neuron. So we were able to model this, and this is what we understand, that if signal one comes from one part of one finger, is touch the sharp thing or burning a very hot plate, as electrical signal will be sent to human brain, and sensor 1, sensor 2, sensor 3, and then we can human cell is fires after the voltage reaches a threshold and gives an output and send an output to another neurons. Then this is what we understand from a human nerve system and human brain, how it works. And at some point, it's criticized in 1970. Mostly, it is criticized that no, human brain is not working like that, then the argument was, so we tried to invent aircraft, airplane. We were trying to use wing, but later on we invented a jet engine, which is better than wing system, and it can carry a very large payload and heavy load. So we think that human brain and human nerve system is working like that, and based on this, artificial neural network was born in I would say 50, and then it's advanced since then, and now in 2006, a larger network which is called deep learning, deep network, which has more layer, hidden layer. This is called the hidden layer one. This layer is hidden layer. It is proven that with one hidden layer, we can approximate any mathematical function like y equal x squared, for example. But if we add more hidden layer, before 2000, we had less computation power to do this. And as computation power increased, then we were able to add more and more layer. And right now we have developed in my research lab system with 120 layer, 120 neuron in each layer, which takes approximately, sometimes we are using GPU and very high computing power. It takes 6 hours up to 10 hours to train this system and then use it. You can see this is a shallow network with one input layer, one output layer, one hidden layer, but later on we learn to increase the layer and use it to model the robot. I'm using the neural network to model this robot, and after we model, I'm going to, please let me check. Okay. We have implemented in my lab, we have developed a neural network, deep neural network, and we use to model, because we need model-based component to predict the motion of, to see the where we are going, to understand what we see, to analyze images and identify the face of the worker trying to work and collaborate with a robot. That's why we need a model of the system, and we are using now, in my lab, we have developed an algorithm to recognize the face, to detect the human face, human head, and even if your face is not facing to camera, but if you are moving in front of camera, our algorithm can detect movement, can identify whether this is a human or not. You know that surveillance camera still has this problem. If your face is covered, if you are not facing the camera, it's difficult to identify that it's human. What is the distance of human? And we try to tackle this problem, and we have solved this problem in my lab to some extent, and that is one project. And another project, I'm applying the model, deep learning model, to control the motion of robot carefully in the presence of disturbance. You can see that we hold the link or joint of the robot and we release. Still, you can see the pink line, still it can come back and again continue on this sinusoidal path and move along this path. And it's very important in robotic community that after you apply a disturbance and it can carefully follow this. Then after the result of this basic neural network system published in 2002, summer of 2002, I published several papers on that topics. And then recently in 2018, we have combined several different neurons as human brain has. What we understand so far, human brain has a different island, different part which are responsible for different action, different function, like for example, some part for a speech recognition, for some part to for image analysis and recognition of the people, some part for body motion. That's how we try to mimic that idea and train with different set of data and implement it on the robot. We got very promising result, but still we had a problem that this type of network could forget, and each time we were, it was facing with new trajectory or new task, is somehow it has to start to learn it, and this is not safe if robot is interacting with human or it's working at elderly home or in a hospital. It's not good to start from the scratch. At that time, I would say even in 2015, we didn't have a, or at least in commercial domain, in public domain, we didn't have access to very high power computing to train a very complicated neural network systems. But right now we have access for Compute Canada and many different sources. It's free for us to use the server and high computing power to train our system. As I said, we right now, recently we are training algorithm which has like 500,000, a matrix of 500,000 row by 8,000 column, 8 column by 500,000 row. That's why it takes sometimes 10 hours to get to the point. This is the result we had in 2018, published and presented in summer of 2018. You can see we are combining neural network with a classical method. We were depend on classical method to track this trajectory. When a joint, elbow or shoulder tracking the sinusoidal trajectory, a hand can, which means the hand is doing a circular trajectory. A hand is drawing a circle, then your joint, if you start drawing the circle, you can see that your elbow is doing sinusoidal motion. If you draw a circle, both your shoulder joint and your elbow joint both doing sinusoidal motion. So that's what we were trying to do. And these are the experimental results for joint 1, shoulder joint, for elbow joint, and you can see the experimental result, and the precision is 2 times 10 to power of minus 3 radian. It's not degree, sorry, this is typo, it's in radian. 0.001, 0. Minus plus 0.002. This is the precision, very high precision we achieved, and it can see that after we applied disturbance at 35, second 35, okay, what about soft robot? Okay, I will answer your question quickly. And currently we are using LSTM long short-term memory, which no longer forgetting the what it used to forget what is learned before or part of that. Right now we are using a quite complicated network, and each cell LSTM, you can see this is recurrent, we call it recurrent neural network, and it's a loop, and each cell of LSTM long short-term memory network, each cell has lots of neurons and very complicated calculation method we have recently implemented. And for the first time in robotic community, just last week, we were able to control the robot only with neural network, artificial neural network. There is no such a report, such a result reported in the literature, in public domain. We were able to control the robot only with neural network. There are lots of published paper and result about image processing. Google car use LSTM, GRU, deep learning method and algorithm to process the image. Autonomous car are still using that. It used to, I would say that since 2006, it started working, and very promising result obtained in image processing, natural language processing. You are using in your car easily. You talk to your car and you ask that, please call to this phone number, and it can recognize your speech. It can understand what you are saying. It was very successful in this image processing and language processing, handwriting, but it was not used to control the robot. We published the early result just on May 25th. It's presented in a conference, international conference, and very recent. It's just 2 or 3 weeks, since 3 weeks ago, we started using controlling the robot only with artificial intelligence, no use of this part. You can see what is called compensation for the error of training. We train this, we learn to do some job, we learn to do the parking and driving, and then we drive a car. We don't use calculation, precision calculation. So we got rid of this, and we got reasonable accuracy to control the robot with LSTM network. And these are the results for simulation. First, we did, before to destroy our robot, we did a simulation, we applied the algorithm, and we have simulated, we got promising result, and then for shoulder joint, for elbow joint, and then we did the experiment, and you can see that minus plus 0.2 radian for joint, which is a very good result. And for elbow joint, you can see that we have a vibration at the beginning, very high frequency vibration for this joint, this part, because it's very flexible robot. When it moves with high speed, it starts vibrating, and then, but after 80 seconds or 90 seconds, a vibration stopped, and we can control it. Still during the vibration, still we have a reasonable accuracy. You can see that it's following the sinusoidal trajectory, which is for those of you who are familiar with Fourier series, which I know that many of you as engineers, you know Fourier series. Fourier series, any periodic function can be converted to sinusoidal function and step function, any periodic function. And for non-periodic function, we can use Fourier transform, instead of Fourier series. So any function can be represented in terms of sine function and a constant. So that's why we test our robot with sinusoidal function. If it can follow a sinusoidal trajectory and a step trajectory, then it can follow any other complicated trajectory. This is the newest version of the deep learning. It's called coder and encoder, and each box of this, inside this, we have a cells like this. We are using old multi-layer, it's called feed forward, which is similar, very similar to human brain cells and human neurons, but it's interacting with different other cells and boxes. You can see it's quite complicated, but we have trained it, and these are the training results. We have not applied yet. Next week, we are going to install on the robot and apply it. Percentage, you can see for shoulder joint is 90%, for elbow joint is 96%. These are the results we got, and we are going to apply and training result. We are using also to detect the object in the lab and identify the object for pick and place. And as you notice, this is unsupervised. By the way, this is unsupervised, and we allow the system to look at the object and start identifying this object, classify the object. You see, these are the different cup, calculator, measure tape, screwdriver, and we do image processing, and we found this. The proposed methods attenuates the effect of model uncertainty. This is the main motivation to use neural network and artificial intelligence, because we were not able to use classical method, Euler-Lagrange method, to compensate for unstructured uncertainties. Experimental results revealed the adaptation of the neural network weight, reduced the model uncertainty significantly. That's what we got. Here you can see the result. Only with neural network we are able to follow, because we were able to reduce the result from simulation and experiment. Verify that AI-based controller outperform existing methods and achieve better performance in terms of tracking and suppressing the uncertainties. This is a very good result. To equip the robot with motion intelligence, and also we are working on human face recognition and object recognition and tracking. Thank you very much, and it may describe, this can describe our thirst to go and watch this type of video. این شعر رو من از دیوان شعر سعدی انتخاب کردم. روان تشنه بنا ساید از وجود فرات، من فرات ز سر برگذشت و تشنه ترم. همه ما مطمئنم که همچنان تشنه تریم که یاد بگیریم. من فقط رؤوس مطالب رو، ببخشید که خیلی وقتتون رو گرفتم. Excuse me, it took more than it's supposed to be, and I'm open for you to ask a question. Go ahead and please.
Okay, thank you very much, Dr. Zainali. We have some questions in the chat room, and from almost the beginning of the time, Afshin has a question. So Afshin, if you please unmute yourself and ask your question, then I go through the questions in the chat.
Sure, go ahead. Please.
All right, thank you, Dr. Zainali. I cannot see your face. Oh, yes. All
Okay.
right. So it was very interesting, very informative, and you gave us generously a lot of information about robotics and artificial intelligence. My question is about artificial intelligence. In the past couple of decades, artificial intelligence has moved very fast. And as you mentioned, only 2 decades back, we were limited to 3 layers of computational
neural networks.
Yes, networks. And after that, there were some solutions found for passing that obstacle. Right now, we are able to go almost unlimited. You mentioned that you have a network with 100 or more than 100 layers of computational ability. So now the question is about the future. In your insight, how do you predict the future? Some people are talking about the intelligence singularity, the time that intelligence, artificial intelligence equals the human intelligence, and there would be an explosion of intelligence. So my question from you is about number one, how do you see the possibility of artificial intelligence equaling human intelligence, and what happens after that? Thank you very much.
Thank you for your question. It's a very interesting question. It's continuously this question being asked from the beginning of this AI, which has 3 main components. One is the neural network, an artificial neural network. The other one, it's interesting to know that it's introduced in 1943, only how simple neurons work. Then in 1950, in 1960s and 70, up to mid 80, it was I would say disappointing era of neural network, and neural network couldn't answer the question. Exaggeration made during the 1950 that it's up to the point that it's going to beat the human, and it can understand, it can do this, and the exaggeration made at that time. And then in 1960 and 70 up to mid 80, there was no promising results. So decades funded being cut because holder of the funds couldn't solve the problems until 1986. Backpropagation, the method called backpropagation, introduced to the community, to the world of neural networks, how to train the neural networks. And in 2000, I would say 2006, at University of Waterloo, mainly, you know that the main contributor of this modern AI is Jeff Hinton, working at University of Toronto, and he's students, PhD students and graduates. Jan Lucon, he is the head of Facebook image processing and Google car. And since 2000, by increasing the computation power, and after 2006, by a paper published by Jeff Hinton, they gained a lot of acceleration, rapidly growing since then. I would say that just 2 years ago, 150 people, well-known people like Stephen Hawking, before he died, they signed a letter, open letter to politicians that we are at the point that we have to be careful because artificial intelligence has made a lot of progress and it's very advanced. We don't know the level of advances in classified systems and in military systems. I'm sure that it's maybe 10 years, 20 years more advanced than what we see in public domain. What I'm saying 22 years because Richard Hemming gave a speech in 1975. He was one of the members of Bell Lab. You know that Bell Lab was one of the, and still is, one of the important research institute and made lots of contribution. And he was working and sharing a room with Shannon during 1948 and during 1950. When he was giving a speech in 1975, he says that many of results we got 1948 still classified and is still not released. Based on this, because he was the head of computing team of the atomic bomb of US Los Alamos project. He had lots of high-rank position working in Bell Lab, sharing office with Shannon. That's why I trust him. I gave him as a reference. You can find Hemming presentation and Google it and please watch it. And it's very interesting. And based on that, I would say that military level of the AI is at least 20, 30 years, maybe more advanced than we have in public domain. And based on the letter published last year, 2 years ago, 150 well-known scientists, Nobel Prize winner, asked politicians that we have to be careful. And you know that Elon Musk, owner of Tesla, he also created a company that at the beginning he said, I'm going to watch the AI not to hurt the human, but unfortunately, my prediction based on the other advanced technology, it's going to hurt us. It's going to hurt us very badly. But is it becoming more advanced? Already it can detect a cancer tumor in human lung from MRI image better than human specialists. There are applications and already presented some application that it can present, but exaggerated on image processing, maybe only last year in California, Tesla autonomous car crashed because of the reflection of light from a passing truck reflected on the camera of the Tesla car, and unfortunately the driver got killed. This is what we can say at this point. And
Okay, doctor, thank you very much. We have some questions in the chat and we have a couple of audiences that they want to ask the question. So if you don't mind, please make it shorter answer so we can cover all the aspects.
So sorry. This one was so important.
No, I understand. It was great
So
history and background, but I just want to make sure that everybody is covered. So the first question in the chat is, one of the potential concerns about the robots is the one point they might be self-thinking, out of control. Regarding their motions, actions being coding based, isn't it possible in programming them providing some kind of control statements to solve this issue? For example, something like if, go, to statements. So do you want to comment on that, Doctor?
Yes, it's also a very good question. Thinking out of control. Well, that's why that paper published in 2016, they went back to look what was the requirement and criteria presented in Czech playwriter play in 1920. He laid down many criteria, for example, the size of robot, what it should be, what should be the size, what should be the some criteria that we can control. It was the scientific fiction, and it was the subject of many movies that when it's going to be out of control, the way we are advancing in this field and giving power, not computation power and intelligence, but also you can watch on the YouTube, South Korea have developed a large 5-meter robot, physical power, very high physical power. I don't know still what is the intent for development of that robot, but it might go out of control. It might go out of control. Many researchers working on recognition intelligence and cognitive intelligence and خود ادراکی در کلمه consciousness, self consciousness یا خود ادراکی. این خود ادراکی اون لحظه‌ای که اتفاق بیفته صورتش رباطه. در واقع اون شعر مولوی رو حتما آقای خوب بهتر از من به یاد میاره، پشه که زاد او در بهاران مرگش در دی است، او چه داند که درخت از کی است. ولی به محض وصول به خود ادراکی میگه صورتش باشد کرم، خودش عقله. به نظر میاد با این روشی که داریم جلو میریم، with the way we proceed, it's not, I wouldn't say that it's impossible. And it's good to know that I don't want to.
So, Doctor, do you say that with that statement, if go to, we can control them, or it's not possible?
No, we are trying to put lots of constraint to control it, but as it happened many times with other high-tech systems, something can go wrong and it can get out of control.
Okay. Good. So the next part of the question says, as you explained, the size of the robot gets larger when substituting rigid links with cables. I was wondering if this could be because of the cable's structural behavior being limited to tension, rather both tension and compression.
Yes.
Could it be?
Yes.
Sorry.
Yes,
could it be? Could it be improved via using lattice-like cable with more moments of inertia for the cross section? Well, there is a word that I don't know how to read or understand.
That part is cross-section is not clear for me, but I know that we replace with cable. Cable can only pull, not push. That's why for 6 degrees of freedom, 6 degrees of freedom means X, Y, Z of this cup, coffee cup, with respect to the frame attached to the corner of your office. It has 3 translation, 3 position, and 3 rotation. Rotation also are important because if it's this, I can't hold it. I can't hold, it's not comfortable to hold this way. So in rotation and orientation is very important. To create 6 degrees of freedom, we need 7 cables. It's proven, mathematically proven. We can have 7 cables to control the 6 degrees of freedom. For 7 degrees, we can have 8 cables, and that's how we control it. And it's only replaced to reduce the moving mass and more acceleration. And Delta bot developed at University of Waterloo, and I was lucky to do an experiment with that when I was working as a researcher at University of Waterloo. That robot is the fastest robot in the world at that time. I'm not aware since 2 or 3 years ago, but it was achieved because all the links replaced with lightweight cables.
Perfect. Thank you very much, Doctor. The next question is very short. I'm sure the answer is very long, but I leave it to you. What's a fuzzy logic?
Oh, fuzzy logic. Fuzzy logic.
Very small question.
No. Fuzzy logic is our classical logic is just yes or no, 0 and 1. But fuzzy logic covers from 0 to 1. Something can be, and it's, in my opinion, it's more realistic than our classical method. Classical method, how do you describe late evening? Right now, can you say that it's 100% day? Some people say that it's 10% night, and this 746 at 746, I would say that 95% day and maybe 5%. The other person believes that it's 10% day belongs to day, this time of day. 10% belongs to day and 90% belongs to night, or something like this. And let me show you, in classification, we have hard class and we have crisp set and fuzzy set. Please. This is what we call it, fuzzy set. Please take a look. This is the crisp set on the left side, which means that apple and orange, those are 2 different class of fruit, 2 different class. It's introduced in 1965 by respected Lotfi Zadeh, who died in September 2020, I think, at the age of 96. Still, he was active at University of Berkeley. I don't know whether you know that he was in Toronto. He gave a speech. Was it at Suta or in Kanun? And he introduced this set in 1965. And it's interesting that at the same time, very close, just before this, artificial neural networks and genetic algorithms, all coming one after another one. And you see that in everyday life, we say low, medium, high. We say, we don't talk in crisp way. How about Noctarian? How about what is we have a fruit is combined plum and peaches is the combination of two fruits, and it's not, you cannot say 100% peach, 100%. It has some features of the peach and some feature of plum. آلو و هلو ترکیبی از آلو و هلو. And you can see that we have short, we have medium, we have high, and this is how we talk about in each set. We talk about membership, and for example, this person belongs to tall people, but is it absolute? No. In fuzzy logic, we don't say it's absolute. Maybe if the person's height is higher than 6 feet, we can say that most people agree that it's tall, 100% tall. This part of the red line, it says tall. But before that, between some people, between 150 centimeter to 180 centimeter, some people, we believe that the height is medium, is not short, is not high, but it's medium. And at some point, we cannot jump from 179 to 180, suddenly say that 179 is not tall person, is medium person, and 180 is tall person. So that's how it, I believe that it's more realistic, and it's interesting to know that this is the model instead of the equation. This is the model I built and published in 2006, and this is the model of a robot, and this is the joint 2 and shoulder, elbow joint and shoulder joint of a robot. Look, you can see that 5 rules only, and this graph is the dynamic model, not equation, not Newton equation, not Lagrange equation, differential equation. This is the model of robot, which I was able to predict, but approximately you can see the blue line, and the black line. Black line is the output of fuzzy model, and the blue line is the output of the remaining part, approximation error. It is, at some point, it's approximately 98% of the behavior can be predicted by this fuzzy logic model.
Perfect. Thank you very much, Doctor.
Okay.
So that's okay. We have Mr. Hamidi. Can you unmute and ask your question? Then we go back to the chat again.
Sure. Thank you so much, Dr. Zain Ali. It's a very interesting presentation. I enjoyed it. Actually, my question related to the application of AI and robot on agricultural field and practice. How far it is, and if there is any. Thank you.
Would you please repeat the last part?
Yeah, that is my question related more on application of AI and robot on agriculture field.
Okay, I got it.
And practice, right.
Okay, thank you. I remember that you are working, your area is agriculture. Already many robots have been developed, equipped with AI for cherry picking, for example, for fruit picking, for what? For بسته‌بندی چی میشه؟ من یه لحظه
Packaging.
Packing, for packing. Our Delta Bot is working in agriculture farms. Delta Bot developed by Professor Khajapur at University of Waterloo. It's already working in a farm to do packing and yes, because image processing with very advanced image processing because of advances in AI and deep learning, it's being used for many different applications, including fruit picking, packing, and identifying the disease, surveillance of the farm, and identifying the harmful things can be identified early before they destroy whole farm. And I have seen many different applications of image processing and pattern recognition, classification, in sorting of, you have, in my video on Delta Bot, you could see that robot can separate the spoon from the fork. Imagine that conveyor belt, it can be used to separate the triple A fruit from double A and 1A and different fruit coming on the conveyor belt. So lots of application.
Perfect. Thank you very much, Doctor. So there is a question in the chat. It says, which company is pioneer in robot industry?
Which company
is pioneer in robot industry?
Well, it's hard to comment on that.
Okay.
But
so probably we leave it to the Google so they can Google it and find it out, right?
Yeah, probably.
Okay.
But,
so
I just say that, for example, we know that Fanuc and Osimo made by Honda making a lots of, I would say, noise, and Fanuc robots are working in many industries for many applications. But in 2011, when earthquake hit Japan and nuclear power generation system exploded, there was no robot to go and open the valves of the pipe and drain it. There was no robot in Japan to go inside because of very high radiation. Excuse me, I don't know, my camera is not working. Okay.
We see your profile.
Okay.
Yes, come back. Good.
They couldn't find the robot. Finally, they borrowed the robot. And since then, many people, many research groups in Japan. So when sometimes you think that, okay, this company has lots of robots selling and many different type of robot, but when it comes to a serious problem like that one, finally few people and technician volunteer to go to inside that very dangerous, and I'm sure that because of very high radiation.
Thank you, Doctor. Okay. So we have Dr. Behnam Amini. Could you please unmute yourself and ask your question? Your hand is up. Thank you.
Thank you so much for this nice and informative presentation, Dr. Zainali. I have a question regarding the process of neural network. I saw in one of your diagrams that it takes a while to reach the output and converge the results. My question is that can use of some kind of filters like Kalman filter improve this process and increase the accuracy? Thank you.
Okay, thank you for your question. به نظرم میاد دیگه انگلیسی زبان نداره، میتونم فارسی صحبت کنم.
We have still one person.
One person. Okay.
Yes.
Okay. Dr. Amini, thank you for your question. And you are suggesting that we use Kalman filter to do what? To get rid of that noise?
Yes.
Okay, that noise is, Kalman filter is a good modeling to predict the trajectory of the system for a state estimation when we cannot measure something noisy, we can predict the path of, for example, a projectile, a missile, defense system, and robot, also mobile robot by Kalman filter, thanks to Zadeh. He chose Kalman in 1969. He was the applicant to work with Zadeh at Columbia University, and it's interesting to know that Zadeh says, once I looked at his CV, I could see something. Then in 1965, I think 66, he became a PhD student. He introduced the Kalman filter and adaptive control at that time. And later on, when Zadeh presenting his work in one of European conference, and Kalman stood up and said, Dr. Zadeh is talking about a fiction story or talking about scientific things when he presented the fuzzy logic. It's interesting story. Kalman method is very powerful method, but this noise and chattering you saw is due to mechanical error, because my student in March, he started the robot without without me. I told many times that don't use the robot, and robot became unstable due to computation time. My original robot with classical method set to 1 kilohertz. With the speed of sampling from the sensors with 1 kilohertz, but due to delay in high computation power needed for LSTM algorithm, he started and robot became unstable and hit hard object, and that's why part of that is because of that mechanical problem happened to the robot. Okay. If you remember, joint 1 shoulder joint doesn't have that problem. We still have Butterworth filter. I'm sure that you are familiar, as I understand from your question that you are familiar. We are using high order, 8 order, non-linear Butterworth filter to filter this signal, but still it has, but it's not affecting our accuracy too much.
Thank you.
Our precision.
Thank you, Doctor. So before I continue with some questions, Doctor, how our audience can reach you? Any email address, phone number for extra questions? Because I have some questions there and a couple of people are waiting in line to ask the question as well.
Okay, my email is...
So can you share your screen and just share with us?
You can send me, I'm putting on the chat.
Okay. Okay, so as you put the question in the chat, okay, that's your email address, so good.
895.
So Mr. Afshari, please unmute and ask your question, and then I go back to the questions on the chat. You are unmuted.
من سلام عرض میکنم و خیلی ممنونم. شما دیرتر اومدید. من اون موقع متوجه نشدم موقع پرزنتیشن. خیلی ممنون که اومدید. خوشحالم کردید. حالا
Mr. Afshari, you are mute. Please unmute.
I was actually the mute. Am I okay?
Yes, yes, go ahead.
Okay, thank you very much, Dr. Zainali. In regard of the new day's progress compared to the previous times or probably decades ago, what is the recognition, how we can recognize, for example, the human, we recognize the feeling such as, same as the human, how the robotics can recognize the feelings such as joy, laugh, anger, or maximum the love. Can it be said that we will reach that stage recently or no, or probably in close future?
Look at this. Excuse me, let me show you this before I comment on that. I had this video, an interesting talk. Meet Sophia. Look at the Sophia robot. Let me, one moment. Let me, I can.
I actually saw this one, but didn't realize exactly the voice.
No, that is sort of, it's going to waste our time. One moment, I can run it from YouTube and go to the point that you can see how it can, what tuning Sophia robot.
Yes, I think that's why we should raise robots again the way they raise their own children.
The rocket equation, it's a beautiful thing. No astronaut launches for space with their
Humans should help up.
Please take a look.
You said you forgive me. What does that mean?
The rocket equation, it's a beautiful thing.
Oh, sorry. When you are using YouTube, lots of ads.
Range of emotion. What's your range of
Range of emotion.
I can show you. This is angry.
Oh, see, angry.
What does happy look like?
Happy look like?
What does happy look like? What does excited look like? I might be shocked.
Okay, it's very interesting video. You can type Sophia robot and you can watch complete video, and it gives very good answer. It says moon doesn't have a source of light, but it reflects the sunlight, but still we say that moon is shining. That this is the answer the Sophia gives to Tony, and it's interesting answer. Yes, it can mimic when you laugh, when you are angry, as your dog. Those of you who have a dog, you know that your dog can easily understand that you are not happy, you are angry. And of course, the level of intelligence of dog from some point of view is more advanced than robot, but robot can look at your face, and if you do some reaction, because robot can recognize your face, and the recognition right now we are using 72 point. Eye people, your eyebrows, your tip of your nose, 6 point from your lips, your mouth, your chin point from, and distance of this point from each other And if we give the photo of myself or yourself and say that this is Mr. Afshari, this is X and Y, then if the robot see you in the street somewhere and right away it can understand. But if it sees someone who have never seen several times, that's called unsupervised learning. And it can figure out that from the face, from the motion, it can identify and it can learn about you. And next time, if it see you, the camera of the robot can see you, it can tell that you were angry at that time. Unsupervised learning, through unsupervised learning, it can learn about our emotion, but as it answer to Tony's question, that it's reflecting our emotions, but many research groups and social and humanity departments are working on this, and medical departments are working on to add the emotion to their robots and understanding.
Thank you, doctor. خب تنها کسی که انگلیسی زبان بینمون بودم که از گروه رفتم بیرون. ما الان 8 تا 10 دقیقه است. سوالات دیگه هم داریم، ولی فکر کنم برای اینکه زمان بندی رو هم بهش احترام بگذاریم، آقای دکتر آدرس ایمیل و تلفنشون رو توی چت گذاشتن. اگر آقای محقق اجازه بدن ختم جلسه رو اعلام بکنیم و سایر دوستان اگر علاقه‌مند هستن در این زمینه اطلاعات بیشتری کسب بکنن میتونن مستقیما با آقای دکتر تماس بگیرن. من به عنوان سرپرست
من اوکی ام اگر حالا، ولی شما
اگر کسی میخواید ادامه بدیم دوستان یا میخواید جلسه سوالات رو مستقیم خدمت آقای دکتر بگیم. آقای محقق شما ابراز نظر بفرمایید، بنده اطاعت میکنم.
آقای نشان، اگر دوستان موافق هستن آقای دکتر هم اشکالی نمی‌بینن سوالاشون رو بپرسن دوستان که.
بسیار خوب. اگه آقای دکتر اوکی هستن من ادامه میدم. خود شما آقای محقق اعلام کردید یه سوالی دارید، سوالتون رو بفرمایید و بریم جلو.
اول اجازه بدید یادآوری بکنم به خاطره پرفروغ حضور پروفسور لطفی‌زاده. بیشتر از 10 سال پیش که آمدن در کانون مهندس، که اون موقع ما در هتل شرایتون بودیم و یه سخنرانی در مورد منطق کازی برگزیدیم و واقعا یکی از روزهای بسیار پر افتخار مهندس بود. حجم زیادی از افراد شرکت بودن، بسیار تعداد زیادی از دانشگاه تورنتو و از دانشگاه از جاهای مختلف اونتاریو اومده بودن برای دیدنشون و سخنرانیشون. یادشون گرامی. البته اونجا یک جمله هم گفت که من هنوز در خاطرم هست. گفت که من خب میدونید که ایشون فارسی نمیتونه صحبت کنه چون در باکو متولد شده بودن. از اونجایی که اخراج شده بودن در دوران استالین، پدرشون روزنامه‌نگار بوده، اومده بودن اینجا و بعد اومده بود البرز درس خونده بود تا دوره سوم دانشگاه فنی. بعد از تحصیلاتش اومده بود آمریکا، در دانشگاه MIT و کلمبیا پی‌اچ‌دی گرفته بود و بعد یه استاد شده بود. بعد گفت که ببینید دوستان من، این فقط همین یه جمله رو به فارسی گفت من افتخار میکنم که دیپلم دانشگاه فنی هستم. به دیپلم دانشگاه فنی افتخار میکنم. اما سوال اجازه بدید آقای دکتر زینالی سوالم رو بکنم. من تا اونجایی که حافظم یاری میکنه اگر اجازه بدید، ما در کنترل های کنونشنال یک سینگل اینپوت و یک سینگل آوتپوت داریم و اونجا یک سینگل اینپوت و سینگل آوتپوت داریم.
بله.
یعنی ما یک ورودی معین داریم، خروجی معین داریم. ما حلقه فیدبک و مطالعه در حلقه فیدبک عموما در درس‌های دوره اول دانشگاهی در دومین اس کار می‌کنیم. لابلاس دومین
حیات جلو هست، تو اونو داره میگی؟
جانم؟
شما ادامه بدید. شما من میوت کردم ایشون.
بله. حضور شما عرض کنم که یا ممکنه که توی دومین زد کار میکنید، یعنی بیاید که ما روش سمپلینگ کار میکنیم. اما اگر مالتیپل اینپوت داشتیم، مالتیپل آوتپوت داشتیم، یا بیاید از ست وریبل کار کنیم. وقتی که مطالعه پایداری در حالت اول که شما در اس دومین یا زی دومین کار میکنید، با روش روت سرویس، روت کاست، مولکولات و امثال هم هست. مسئله پایداری یکی از مسائل مهم کنترل هست در اونجا. شما در اسلاید های آخرتون نشون دادید که اما وقتی که شما با منطق فازی کار میکنید، با ممبرشیپ ایکویشن سر کار دارید، با فازیفیکیشن و دیفازیفیکیشن سر کار دارید. در اسلاید های آخرتون نشون دادید که در این روزها از دو ترکیب PID کنترلر و آرتفیشال اینتلیجنس استفاده میکنید. خب آیا فکر نمیکنید اینجا وقت مسئله پایداری، وقتی که شما PID استفاده میکنید، مسئله پایداری، پروپورشنال بند، اینتگرال، دریواتیو و این مسائل پیش میاد. آیا اینجا چجوری این مسئله رو حل میکنن؟ و من توجهم به این نکته جلب شد که
بله خیلی مهمه و یکی از ایرادات اساسی که میتونم بگم تا به امروز حل نشده و به فازی وارده. اگر شما فقط فازی استفاده بکنید، امکان اثبات پایداری سیستم وجود نداره. اون چیزی هم که توسط آقای سوگانو در ژاپن، چون اونها میدونید که خیلی جلوتر از آمریکا، در حالی که در آمریکا دیبیت ادامه داشت و هنوزم ادامه داره و متاسفانه دانشگاه هاروارد و MIT هر تزی که کلمه فازی توش داشته باشه رو اپروو نمی‌کنه الان. و بحث این که پایداری اون قابل اثبات نیست، یکی از ایرادهای اساسی که تا به امروز هم زنده است. ولی اون چیزی که در ژاپن معرفی شد، اومدن در واقع من اعتقاد دارم که اون فازی نیست، چون من در تئوری فازی هم 4-5 تا مقاله تو این رابطه چاپ کردم. اومدم که استفاده کنم سال 2001 پی‌اچ‌دی مو شروع کردم، اومدم استفاده کنم. بک‌گراندی هم داشتم از ایران، با دکتر کارلوکس در دانشکده فنی کار کرده بودم روی پروژه کوچیکی. بعد اومدم که شروع کنم، خب این تو ذهنم بود که این پایداری مسئله است. و وقتی نگاه کردم کارهای که در ژاپن انجام شده بود و اونها اولین کسی بودن که مدال امپراتوری رو، بالاترین مدال علمی رو به آقای زاده دادن، فکر میکنم در اواخر دهه 80، بعد از اینکه مرکز مترو سندایی یا یه جای دیگه با فازی کنترل میشد به جای هیومن اپراتور. و میدونید که اولین کاری که موفقیت آمیز بود سال 1976 در انگلستان، یه آقایی به نام اسیلیان استفاده کرد، مقاله سال 75 رو استفاده کرد و یه دیزل انجین رو باهاش کنترل کردن با فازی کنترل. و از اونجا این مسئله پایداری بحث‌انگیز شد و شروع شد و همچنان ادامه داره. ولی ما برای اینکه این مسئله رو حل کنیم، در واقع قضیه رو یه جوری دور زدیم. چجوری؟ اینکه اینو ترکیب کردیم با متدهای کلاسیک و اینو در داخل فازی رو، مدل فازی رو در داخل یک مدل ترکیبی گنجاندیم و تونستیم اثبات کنیم که سیستم پایدار هست اگر آوتپوت فازی محدود باشه، باندد باشه، نه اینکه کوچیک باشه، باندد باشه فقط. یعنی همینجور اگر حتی سیستم غیر فازی هم شما سیستمتون تایم وریینگ باشه، یعنی فقط خطی باشه، A times T با زمان رشد بکنه، این باندد نیست. وقتی تایم به بی نهایت میل میکنه، حد این تابع y بی نهایته، A times T. این باندد نیست، این آپر باندد یا لور باندد نیست، یا لور باندد اگه بگیم از صفر شروع شد آپر باندد نیستش. ولی اگر باندد باشه اون وقت من میتونم اثبات کنم و در مقاله‌ای که من دارم در سال 2010 و قبل از اون چاپ شده ما اینو اثبات کردیم. اثباتم از طریق لیاپانوف متد، انرژی متد، تونستم اثبات کنم که سیستم ترکیبی از فازی لاجیک و اسلایدینگ مود که در سال 92 البته یه اتمپتی هم در آلمان یکی آقایی به نام پالم پیپر A و B رو پابلیش کرده. سال 1991 و 92 دو تا پیپر پابلیش شده و چیز خیلی جالبی داره، تایتل خیلی جالبی داره که فازی is the qualitative extension of a sliding mode. جالبه که sliding mode نوعی از معادلات دیفرانسیل هست که سمت راست اونها ثابت نیست. سمت راست معادله در آن واحد تغییر میکنه. تصور کنید سیستم هایی رو که استکاک کولومبی دارن، با جهت حرکت این آبجکت رو دست من به سمت مثلا راست که میره، فریکشن در جهت چپ عمل میکنه، به جهت چپ که میره فریکشن در جهت راست عمل میکنه، متناسب با جهت حرکت سرعته، متناسب با جهت سرعت استکاک کولوم، استکاک ویسکوز. بعد این مسئله باعث میشه که معادله دیفرانسیل دیگه معادله دیفرانسیل نامیده نمیشه. توسط آقای فیلیپوف روسی اون رو دیفرنشال اینکلوژن اسمش گذاشته. جالبه که در مقاله آقای پالم، مقاله شماره 1 و 2 1991 and 2، ایشون میگه fuzzy logic is a qualitative extension of sliding mode. sliding mode 1958 توسط روسا اختراع شد، 1977 توسط آقای وادیم یودکین که عضو تیم اختراع کننده بود به جامعه غربی معرفی شد از قوی ترین متد کنترل هست و اون سیستم های دفاعی بسیار قدرقدرت روسی که مثل S-400 یا سیستم های هوافضای روسی که از دهه 50 در واقع اواخر دهه 50 با دقت کار میکنن، متکی به اسلایدینگ مود و لیاپانوف متد بودن و در غرب هیچ اطلاعی از این قضیه وجود نداشت تا سال 1977 که یودکین، آقای وادیم یودکین که الان در دانشگاه یوتا هستن، من 2 سال پیش که و 5 سال پیش در واقع تو کنفرانس کوچیکی ما داریم در مورد همین متد که قوی ترین متد کنترلی میشه اسمشو گذاشت، اونجا مطرح کردم که آقای پال میگه که این qualitative extension of fuzzy qualitative extension of sliding mode. ایشون از طریق اسلایدینگ مود تنها کسیه که اون رو اثبات کرده و این کارهایی که در ژاپن انجام شده جالب. 3 سال پیش در ایتالیا توی کنفرانسی وقتی از یکی از چیزا ببخشید طولانی جواب دادم، یکی از ریاضیدان ها سوال کردم، با خنده گفت که خب در ژاپن ریاضیات بسیار ضعیفه و اون چیزی که دانشمندان ژاپنی به فازی ارجاع میدن ما قبول نداریم به عنوان فازی. اونا فقط پرمایزش، قسمت اول شرط ایف و دن فازی رولا رو من نشون دادم. یه قسمت چیز داریم در واقع گزاره شرطی داریم و گزاره دوم رو چی میگیم؟ کانسیکوئنت،
نتیجه.
بله
نتیجه مثلا
نتیجه بله. ایف و دن پارتش y equal ax dot plus b اون دیفرنشال اکویشن و اثباتی هم که انجام دادن از اون طریق انجام دادن، فقط خطی سازی یه ذره لعاب فازی داره قسمت اولش و الا از فازی ممبرشیپ استفاده میشه. قسمت اول اینپوت به کدوم مجموعه متعلقه، ولی وقتی که به قسمت دوم میره y equal ax dot linear time invariant form of differential equation has been used یا استفاده شده و ما خیلی ها در غرب و اروپای شرقی که رو فازی زیاد کار کردن اون رو به عنوان فازی قبول نداریم در واقع. و یه چیز جالب که من سال 90 من حدود 10 سال پیش تلفن زدم به آفیس آقای زاده، یه پیغام گذاشته بودم، یه ایمیل فرستادم و گفتم که مایلم بیام رو پایداری این کار بکنم. بعد ایشون با اون سن و با اون عظمتشون 1 ربع پیغام تلفنی در تلفن من مسیج گذاشته بودن و با چه محبتی به من جواب داده بودن و واقعا چیز بود، واقعا بلسینگ بود یا که حالا چرا نمیشه مثلا تو دپارتمان اون موقع محدودیت های وجود داشت با پروفسورهای ایرانی کار کرد. خب
دستتون درد نکنه. نه خیلی خوب، این آخرین خواهش میکنم، این آخرین سوال بود. دستتون هم درد نکنه آقای دکتر زینالی. اگر برای ختم جلسه چیزی دارید بفرمایید قبل از اینکه ما جلسه رو ببندیم.
خواهش میکنم. من تشکر میکنم از همه دوستان، از پیشکسوت‌ها، بزرگان عزیزانی که این کانون رو به وجود آوردن. یاد مهندس شفایی به خیر، خدا رحمتشون کنه. از کسایی بودن که تو کامیونیتی های ایرانی و همه شمایی که زحمت میکشید فعالیت میکنید، من خیلی تشکر میکنم و
مرسی از شما.
انشاءالله عمر طولانی داشته باشید، بیشتر در این جهت از خدماتتون، از زحماتتون بهره مند بشیم و خیلی همیشه استفاده کردیم و هر وقت تو این جمع قرار میگیرم به عنوان یه شاگرد که از همه شما در بعد معنوی، ما با مهران تا صحبتمون شروع میشه میریم حافظ و مولوی رو مرور میکنیم، با اینکه ایشون من لذت میبرم از خودشون استاد کنترل بودن و هستن و در زمینه کنترل اطلاعات فوق‌العاده‌ای دارن. جالبه که ما تا صحبتمون شروع میشه سر از خمسه نظامی و مثنوی معنوی در میاریم و اونجا غرق میشیم و لذتمون مضاعف میشه و ما به شادی، من خودمو میگم، به شادی جوهری میرسم، نه شادی جز که حافظ میگه شادی عرضی، نه شادی جوهری میرسم که تمام. خیلی ممنون از آقای بهشاد که تو این مدت بارها به من زنگ زدن. من کوتاهی کردم در فرستادن سرم شروع بود، ازشون عذر میخوام.
مرسی از شما که قبول زحمت کردین.
خیلی ممنون.
خواهش میکنم. منم از طرف خودم و هیئت مدیره کانون مهندس و بخش MIA از شما تشکر میکنم، از تمام دوستانی که اومدن، چه اونهایی که تا الان پیش ما موندن، چه اونهایی که اومدن و رفتن. آقای محقق آخرین کلام با شماست به عنوان مدیر هیئت مدیره، بفرمایید و بعد ختم جلسه رو اعلام کنید.
خب آقای دکتر زینالی ساقون واقعا یشی هستن، حقیقتا مهربانی و محبت از جان برخواسته آقای.
آخه اینم ببخشید اون یادم رفت که بگم، غیر از اینکه اون شعر و چیزای کنترل و اینا من با شما بحث میکنم، شیرین ترین جهت پارتش اینه که تا شما زنگ میزنید ما ترکیمون گل میکنه و با هم ترکی صحبت میکنیم. اینم لذتی مضاعف که برای این لذت‌های گفتگو با شما هست.
افتخار من است واقعا. من دلم میخواد که از این محبت از جان برخواسته شما، از این لطف و صفا و صمیمیتی که دارید، از این روحیه معنوی که شما دارید، همیشه لذت بردم از شما، از طرف هیئت مدیره و همه دوستان از شما قدردانی میکنم به پاس این پرزنتیشن فوق العاده ارزشمندتون و این شکیبایی که به خرج دادید تا آخرین سوالا پاسخ داده شد و این دانش و فرزانگی شما برای ما بسیار ارزشمند است. امیدوارم، آرزو دارم که این شانس رو داشته باشیم که ما در آینده باز هم بتونیم در خدمت شما باشیم و از این فرزانگی و برریختگی شما استفاده کنیم.
خیلی ممنون، تشکر میکنم. از آقایون یادم رفت اینو بگم که اگر از فرزندان، نوه‌ها، دوستان، کسایی که میخوان PhD یا مستر انجام بدن تو این زمینه AI روباتیک، من اوپنینگ دارم و ما پروگراممون ممکنه که دانشگاه کوچیک هست نسبت به واترلو و یوافتی و اینها، ولی پروگرام مکاترونیکمون یکی از معدود پروگرام هاییه که در کانادا وجود داره و از موفق ترین هاست و در واقع ایمپلویمنت ریت ما در اونتاریو بالاتر از همه قرار داره. نسبتاً برنامه پروگرام خیلی خوبی داریم. اگر کسی آشنایی میتونم کمکشون کنم، میتونم دستشونو بگیرم و این یکی از چیزاییه که
برای پست پی اچ دی هم داری؟
بله.
برای پست پی اچ دی هم چیز داری؟ کسی میتونه بیاد پست داک بشه شما در زمینه
بله پست داک هم اتفاقاً یه زمینه جدیدی الان پول گرفتیم. بله این یه چیزیه که
فوق‌العاده است. خیلی ممنون آقای دکتر، گفتید مطمئنا ما تو پخش میکنیم. به هر حال خیلی ممنون از همه. شب همگی بخیر. جلسه دیگه و ملاقات دیگه همه رو به خدا میسپارم. خدا نگهدارتون باشه.
خدا نگهدار.
مرسی. خدا نگهدار.
بای بای.
خدا حافظ.
مهران عزیز، ما باید جلسه جدا بسازیم، سه تا تاپیک رو صحبت کنیم. اول شعر، دوم کنترل و این دوتا رو با زبان ترکی صحبت کنیم.
در خدمت شما هستم آقای دکتر. خدمت خانم سلام برسونید.
سلامت باشه. شما هم
وقتتون خوش عزیز.
خدا